November 17, Paper 1H, question 23. Here is a rectangle and a right-angled triangle. All measurements are in centimetres. The area of the rectangle is greater than the area of the triangle. Find the set of possible values of x. So we need expressions for the areas of these two figures, and the left-hand one's greater than the right-hand one. So the left-hand one, length times width for a rectangle, 3x minus 2 multiplied by x minus 1 is greater than the area of this right-angled triangle, which is a half times the base times the height. Expand these brackets, we get 3x squared minus 2x minus 3x plus 2. And that has to be greater than, the 2's cancel, and we're left with x squared. Let's bring everything to the left-hand side, and we get 3x squared minus x squared is 2x squared, minus 2x minus 3x is minus 5x, plus 2 is greater than 0. Now I need to factorise this expression. So if we multiply the 2 at the front by the 2 at the back, 2 times 2 is 4, and I want factors of 4 that add up to minus 5. Well, that would be minus 1 and minus 4. So I can split the minus 5x into minus x, minus 4x, and that will help me factorise it. So I factorise the front two terms. As a common factor of x, rebuild the expression, I'll need 2x minus 1. That gives me the 2x squared minus x. And if this expression factorises, that will also be a factor at the back. Now what could I multiply that bracket by to give minus 4x plus 2? Answer, minus 2. And that means I've got a bunch of 2x minus 1s. How many have I got? I've got x minus 2 of them. And that's greater than 0. Now what I want to do now is draw a little graph, a quadratic graph. Which values of x make those brackets 0? Well, the first one, when x is 2, that would be 0. And the second bracket, if x was a half, 2 halves minus 1 would be 0. So that would give me 0 as well, a half and 2. And if I drew the graph of y was 2x squared minus 5x plus 2, it would look like that, like a piece of string dangling and crossing the x-axis at a half and 2. So when is this expression greater than 0? You can see it's when it's bigger than 2 or less than a half. So at the moment I'm thinking the answer could be x is greater than 2 or x is less than a half. Now are both of those possible? Let's go back to the diagram. Well, x could certainly be bigger than 2, but it couldn't be less than a half, because if we look at the length at the top, 3 halves minus 2 would be negative, and we can't have a negative length. We're okay with a 2 because 3 2's are 6 minus 2 would make the top 4, and 2 minus 1 at the side would make that 1. So that answer is not possible in this context. So the set of values we want that make this possible, with the left-hand area being greater than the right, is the set of values x is greater than 2. And that completes the paper.